In the early 1990s, the skies over the Pacific were dominated by a single, undisputed reality: the overwhelming technological superiority of the West. For decades, the People's Liberation Army Air Force of China had been viewed by military analysts as a flying museum. While the United States was deploying the 15 Eagle and the F-16 Fighting Falcon jets, equipped with pulse Doppler radars and fly-by-wire systems, the Chinese pilots were still strapped into cockpits that would have looked familiar to a veteran of the Korean War. Their frontline strength consisted almost entirely of J-6s and J-7s, which were essentially indigenous clones of the Soviet MiG-19 and MiG-21. These were rugged, simple machines designed in the 1950s, and by the time the Cold War began to thaw, they were hopelessly outmatched. To the generals in Beijing, the 1991 Gulf War served as a terrifying wake-up call. They watched from the sidelines as American high-tech weaponry dismantled one of the world's largest conventional armies in a matter of weeks. It became painfully clear that in a modern conflict, courage and numbers meant nothing if you were fighting in the digital dark. China's air defense was a paper tiger, and the steel wall they had built was crumbling. But as the Soviet Union collapsed into the dust of history in 1991, a window of opportunity opened that no one could have predicted. Moscow was in chaos. The once mighty Soviet military-industrial complex was starving, and its engineers were literal days away from poverty. The new Russian Federation was desperate for hard currency, and for the first time in history, the crown jewels of Soviet aviation were for sale. Beijing, fueled by an exploding economy and a desperate need for modernization, arrived at the table with suitcases full of cash. They didn't want the hand-me-downs or the export-grade shells that Moscow usually sold to the Third World. They wanted the best. They wanted the Predator that had been designed specifically to kill the 15 Eagle. They wanted the Sukhoi Su-27, known to NATO by the menacing codename Flanker. To understand the shock this sent through the Western intelligence community, one has to understand what the Flanker represented in 1992. It was not just a plane, it was a masterpiece of aerodynamic art. When the Su-27 first appeared at Western air shows, it performed maneuvers that seemed to defy the laws of physics. The world watched in stunned silence as a massive twin-engine fighter pulled its nose up past the vertical, coming to a literal halt in midair before falling back into level flight, a move known as the Cobra. It was a beast of a machine, carrying a massive internal fuel load that gave it a staggering combat radius of over 3,000 kilometers without the need for external tanks. It possessed a radar so powerful it could burn through Western jamming, and carried an arsenal of 10 air-to-air missiles that could track and kill targets from beyond the horizon. For the first time, a Russian designer had created an airframe that was not just equal to the West, but in many ways superior. And now, this ultimate predator was being handed over to the most populous nation on Earth. The arrival of the first batch of 24 Su-27s at Wuhu Air Base in June 1992 changed the balance of power in Asia overnight. For the United States and its allies in the region, the flanker shock was a geopolitical earthquake. Suddenly, the vast distances of the South China Sea and the Taiwan Strait didn't seem so vast anymore. The People's Liberation Army Air Force had leaped over 2 generations of aviation technology in a single bound. They had gone from flying supersonic bricks to piloting the most dangerous dogfighter in the world. But as the Russian transport ships unloaded the massive blue and gray camouflage jets, the engineers in Moscow believed they had simply secured a desperate, long-term customer. They saw China as a student that would forever depend on the master for engines, spare parts, and missiles. They were wrong. What the Russians viewed as a commercial lifeline, the Chinese viewed as a blueprint for the future. This wasn't just a purchase to fill a gap in their inventory. It was the beginning of a strategic heist. Beijing wasn't just buying the planes. They were studying the rivets, the software, the composite materials, and the complex curves of the airframe. The Su-27 was the Trojan Horse that would allow China to bypass decades of failed research and development. Behind the closed doors of the Shenyang Aircraft Corporation, a secret plan was already in motion to not just fly the flanker, but to own it, to strip away its Russian soul and replace it with a Chinese heart. This was the opening act of the betrayal of the Sukhoi, a story of high-stakes espionage, broken contracts, and an engineering evolution that would eventually see the student surpass the master. In the early 1990s, the world was focused on the end of the Cold War, but in the hangars of Wuhu, a new and far more complex rivalry was being born in the scream of the Leapfrog Saturn engines. The flanker had arrived in China, and the Pacific would never be the same again. By the mid-1990s, the geopolitical landscape had shifted into a state of surreal irony. The Russian Federation, once the heart of a superpower that threatened to overwhelm the world with its industrial might, was now a nation on its knees. The transition from a planned economy to a raw, unchecked capitalism had left the country in a state of hyperinflation and social chaos. In the city of Moscow, the grand hallways of the Sukhoi Design Bureau were cold, and the engineers who had spent their lives perfecting the art of supersonic flight were suddenly wondering how they would pay for bread. The pride of the Russian military-industrial complex was for sale, not because of a change in ideology, but because of the brutal, crushing need for survival. This was the era of the fire sale, and the People's Republic of China was the only customer with a wallet deep enough to buy the future. In 1996, the two nations signed a landmark agreement that would forever be known as the birth of the J-11. It was a staggering $2.5 billion contract, but it wasn't for the purchase of completed aircraft. Instead, Russia agreed to something far more significant: a licensing deal that would allow China to produce 200 Su-27 SK fighters on its own soil. The production would take place at the Shenyang Aircraft Corporation, a massive industrial complex in northeast China that had spent the last several decades churning out aging clones of the Mi-21. For the Russians, this deal was a financial lifeline, a desperate infusion of cash that would keep the Sukhoi Bureau alive for another decade. For the Chinese, it was the ultimate Trojan Horse. They weren't just looking for a new fleet of fighters. They were looking for a masterclass in modern aerospace engineering. The atmosphere in Shenyang during the mid-1990s was one of intense, feverish activity. This was the Great Tech Transfer, a period where the student and the master lived side by side in a strange, transactional embrace. Hundreds of Russian engineers, many of them the original designers of the flanker, were flown to China to set up the assembly lines. They lived in austere dormitories and worked 10-hour days on the factory floors, teaching Chinese workers how to handle the exotic materials that made the Su-27 possible. They taught them how to weld titanium, how to shape the complex bird-like curves of the fuselage, and how to calibrate the sensitive flight control systems. At the time, the Russians believed they held the upper hand. The contract was structured so that China was merely an assembler. The planes arrived in Shenyang as kits, massive crates filled with thousands of parts that had been manufactured in Russia. The Chinese workers would put them together like a giant, high-stakes jigsaw puzzle. Moscow's confidence was rooted in a very specific, calculated risk. While they were willing to teach the Chinese how to build the body of the flanker, they guarded the brain and the heart with paranoid intensity. The sophisticated N001 radar and the powerful Leapfrog Saturn AL-31 engines remained strictly Russian territory. These components were delivered as sealed units. The Chinese were allowed to install them, but they were not allowed to open them, let alone manufacture them. The Russian leadership believed they had created a customer for life. They assumed that even if China built 200 airframes, they would always be tethered to Moscow for the high-tech subsystems that actually made the plane a weapon. They viewed the J-11 project as a colonial factory, a place where Chinese labor would assemble Russian genius for a Chinese price. However, the view from Beijing was entirely different. Inside the Shenyang Aircraft Corporation, the atmosphere was less like a factory and more like a massive, three-dimensional laboratory. The Chinese leadership had no intention of remaining a mere assembly line for Russian parts. Every crate that arrived from Russia was treated as a textbook. While the Russian engineers were teaching the workers how to turn a wrench, Chinese scientists were in the back rooms using advanced three-dimensional scanners to map every millimeter of the airframe. They were analyzing the chemical composition of the alloys, studying the logic of the wiring harnesses, and reverse engineering the software that managed the jet's flight stability. The Su-27 was being dissected with the precision of a surgical operation. This was a massive, nationwide effort to bridge a 40-year technological gap in a single decade. The Chinese government poured billions into digesting the Russian technology. They knew that as long as they relied on Moscow for the engines and the radar, their air force was effectively under Russian control. The goal of the J-11 program was not just to produce aircraft, but to achieve total indigenous capability. This was the true nature of the Trojan Horse. While Russia was looking at the $2.5 billion in their bank account, China was looking at the blueprints for the most advanced air superiority fighter in the world. They were learning the secrets of the flanker from the very men who had built it, and they were doing so with an efficiency that the Russians had never anticipated. By the late 1990s, the first locally assembled J-11s began to roll off the line in Shenyang. To the outside world, they looked identical to the Russian-made Su-27s. The Russian advisors were proud, seeing the fruits of their labor and the survival of their industry. But beneath the surface, the relationship was beginning to sour. The Chinese engineers were starting to ask why, instead of just how. They began to suggest improvements to the assembly process and raised questions about the limitations of the Russian radar systems. The Russians, still feeling superior, dismissed these concerns, confident that their monopoly on the engine and avionics would keep China in line. They did not realize that the student had already finished the textbook and was now beginning to write his own chapters. The stage was being set for a confrontation that would stun the global arms market. Russia had sold the Trojan Horse to save their present, but in doing so, they had handed China the keys to the future. The betrayal of the Sukhoi was no longer a question of if, but when. By the mid-2000s, the atmosphere of cooperation that had defined the previous decade began to chill into a state of profound suspicion. For years, the Russian aerospace industry had relied on the steady flow of Chinese capital from the J-11 licensing deal to keep its lights on and its engineers fed. In Moscow, the leadership of Sukhoi and Rosoboronexport viewed the relationship as a permanent fixture of the new global order, a symbiotic bond where Russian genius provided the blueprints and Chinese labor provided the scale. They expected the Shenyang Aircraft Corporation to continue ordering crates of Russian parts for decades to come. But in 2004, the wind shifted. In a move that sent shockwaves through the halls of the Kremlin, the Chinese government abruptly announced that they were terminating the contract for the remaining 95 aircraft kits. Their reasoning was as blunt as it was insulting to the Russian designers. They claimed the Su-27SK was no longer technologically relevant to the needs of a modern battlefield. They called the masterpiece of Soviet engineering obsolete. To the Russians, this claim was absurd. The flanker was still one of the most formidable air superiority fighters in existence, but the insult was merely a smokescreen for a much more ambitious reality. For nearly 10 years, the student had been quietly studying the master's work, and by the mid-2000s, the Chinese had decided they no longer needed the teacher. Just a few years after the contract was torn up, a new aircraft began to appear on the runways of northeast China. At a distance, it looked identical to the Russian Su-27. It had the same aggressive sloped nose, the same massive twin engines, and the same elegant, bird-like silhouette. But as Western and Russian intelligence agencies scrutinized the high-resolution satellite imagery and the few leaked photographs, they realized they were looking at something entirely different. This was the J-11B. In the eyes of the Russian aerospace community, that B did not just stand for a new variant. It stood for betrayal. The J-11B was a declaration of total industrial independence. While the outer skin looked like a Sukhoi, everything beneath that skin was the result of a massive, decade-long effort to sinicize the aircraft. The Chinese engineers had accomplished what the Russians thought was impossible. They had completely gutted the flanker and replaced its Russian soul with a Chinese one. The old, heavy, and increasingly temperamental Russian N001 radar was gone, replaced by a modern, domestically produced pulse Doppler system capable of tracking more targets at greater ranges. The analog soul of the cockpit, the forest of circular dials and mechanical switches that had defined Soviet aviation since the 1950s, was swept away. In its place was a sleek, Western-style glass cockpit, featuring multifunction liquid crystal displays and a sophisticated head-up display that allowed the pilot to manage the battlefield with a fraction of the effort. But the most significant change, the one that truly cut the cord of dependency, was hidden deep inside the engine nacelles. For years, Russia had believed that their monopoly on the AL-31 engine was their ultimate insurance policy. They believed that China simply lacked the advanced metallurgy and the specialized knowledge of turbine blade manufacturing to build a high-performance jet engine. They were wrong. The J-11B was powered by the WS-10 Taihang, a Chinese-made turbojet that represented the culmination of one of the most difficult engineering projects in the nation's history. The development of the WS-10 had been plagued by failures, fires, and catastrophic breakdowns during the 1990s, but by the mid-2000s, the Chinese had pushed through. The heart of the aircraft was now Chinese. This meant that Beijing could now mass-produce flanker derivatives in any quantity they desired, without ever having to ask for Moscow's permission or pay a single ruble in royalties. The reaction in Moscow was a mixture of stunned disbelief and white-hot fury. The Russian government realized they had been the victims of one of the greatest industrial heists in history. They had sold the Trojan Horse to save their economy, and now that horse had opened its gates to reveal a rival that was ready to drive them out of the market. Russian officials accused China of blatant intellectual property theft, arguing that the J-11B was an illegal copy that violated every spirit of the original licensing agreement. There were heated closed-door meetings where Russian diplomats reportedly shouted at their Chinese counterparts, accusing them of eating the hand that fed them. The Russians felt a deep sense of personal betrayal. Many of the engineers who had lived in Shenyang and taught the Chinese workers felt that their generosity and mentorship had been weaponized against them. However, the Chinese response was one of cool, pragmatic indifference. They argued that because they had replaced the internal systems, the radar, the cockpit, and the engines with indigenous technology, the J-11B was a new aircraft that just happened to share a similar aerodynamic shape. They pointed out that they had spent billions of their own money to modernize a platform that Russia had refused to upgrade for them. In the eyes of Beijing, the student had not stolen from the master. The student had simply graduated and built a better school. The relationship that had once been a partnership was now a fierce competition. The J-11B was not just a plane. It was a symbol of China's arrival as a first-tier aerospace power. This moment changed the balance of power in the global arms trade forever. Russia, once the sole provider of high-end weaponry to the developing world, suddenly found itself competing against its own technology. Technology that was now being offered with better electronics, more modern cockpits, and often at a lower price point. The flanker was no longer a Russian monopoly. As the 2010s approached, the J-11B began to fill the ranks of the People's Liberation Army Air Force, becoming the backbone of a new, assertive China. The heist was complete. Russia had learned a bitter lesson about the price of desperation. While China had proved that in the world of high-stakes military engineering, there is no such thing as a permanent friend, only permanent interests. The birth of the J-11B was the end of the flanker as a Soviet legend, and the beginning of its life as a Chinese powerhouse. In the history of military aviation, the term copy usually carries a heavy weight of derision. Throughout the 1950s and 1960s, a clone was almost always a faded photocopy of the original, a machine built with inferior materials, less capable electronics, and a shorter lifespan, intended only to provide a cheaper alternative for nations that could not afford the real thing. When the world first saw the Chinese J-11B, many analysts dismissed it as just another one of these hollow imitations. They assumed that without the direct guidance of Russian engineers, the Chinese aerospace industry would eventually hit a ceiling, unable to keep pace with the rapid digital evolution of the 21st century. However, those analysts underestimated the sheer scale of China's industrial ambition. By the early 2010s, the mission in Shenyang had shifted. They were no longer interested in simply replicating the Sukhoi design. They were intent on perfecting it. This was the transition from the era of the clone to the era of the evolution, and the result was an aircraft that would eventually make its Russian ancestors look like relics of a bygone age, the J-16. To understand the J-16, one must first look at the machine that served as its inspiration, the Russian Su-30M KK. This was the heavy, twin-seat, multi-role variant of the flanker family, a brute of an aircraft designed to carry massive payloads of bombs and missiles over long distances. While the early J-11 was a pure air superiority fighter, the J-16 was designed to be the Swiss Army knife of the People's Liberation Army Air Force. But where the Russian Su-30 relied on heavy steel and aluminum alloys rooted in 1970s metallurgy, the Chinese engineers began a radical process of weight stripping and structural refinement. They replaced large sections of the airframe with modern composite materials and high-strength carbon fiber. This wasn't just about making the plane lighter. It was about making it stronger and more durable. By reducing the structural weight of the airframe, they allowed the J-16 to carry more fuel and more advanced weaponry without sacrificing the legendary agility that made the flanker airframe famous. It was as if they had taken a classic heavyweight boxer and given him the speed and stamina of a middleweight. However, the most profound leap forward occurred inside the nose of the aircraft. For decades, the greatest weakness of Russian-designed jets was their avionics. Russian radars were traditionally heavy, power-hungry, and easier to jam than their Western counterparts. While the latest Russian variants were still using passive electronically scanned array radars, China made the strategic decision to leapfrog directly into the next generation. The J-16 was equipped with a massive, indigenous active electronically scanned array, or AESA, radar. This was a total game-changer. An AESA radar is made up of hundreds of tiny, independent transmit-receive modules, allowing the jet to scan the sky with multiple beams simultaneously. It is faster, more precise, and incredibly difficult for an enemy to jam. More importantly, it gave the J-16 the ability to detect and track low observable or stealth targets at much greater ranges than any previous flanker variant. The copycat had suddenly developed eyes that were sharper than the master's. This digital superiority extended into the cockpit and the electronic warfare suite. The J-16 was built from the ground up as a net-centric fighter. It was designed to talk to satellites, early warning aircraft, and even ground-based sensors in real time, creating a shared picture of the battlefield that the older Russian jets simply could not match. The Chinese engineers also integrated a highly sophisticated electronic warfare system with sensors embedded across the skin of the aircraft that could detect and categorize enemy radar signals instantly. This allowed the J-16 to act as a mini AWACS, coordinating strikes and providing electronic cover for smaller fighters like the J-10. By the mid-2010s, It was clear that the J-16 was no longer a clone. It was a radical modernization that used the Sukhoi airframe merely as a chassis for some of the most advanced digital technology on the planet. But a hunter is only as good as its weapons, and it was in the realm of missiles that the J-16 truly began to outclass its original creator. Because the Chinese had total control over the aircraft's source code and fire control systems, they could integrate their latest and most lethal snipers of the sky. This included the PL-15, a long-range air-to-air missile equipped with its own AESA seeker and a dual-pulse rocket motor. With a range estimated to be over 200 kilometers, the PL-15 allowed the J-16 to strike enemy tankers and early warning planes from well outside their defensive zones. Even more terrifying was the integration of the PL-17, a massive, ultra-long-range missile designed specifically to kill high-value targets from nearly 400 kilometers away. Russian flankers, tied to older missile technology and less capable radars, found themselves outranged and outmatched in the very arena they were designed to dominate. As the J-16 entered mass production and began to fill the frontline regiments, the narrative in the global defense community began to flip. People stopped talking about Chinese copies and started talking about Chinese innovations. The J-16 proved that China had mastered the most difficult part of aerospace engineering: the integration of complex, disparate systems into a cohesive and lethal whole. They had taken a Russian masterpiece and fixed every one of its flaws, improving its range, its vision, its stealth detection, and its reach. In many ways, the J-16 was the plane the Russians had always wanted to build but lacked the microelectronics industry and the capital to realize. By the late 2010s, the J-16 had become the backbone of China's aerial power, a heavy-hitting multi-role platform that could do everything from deep strike missions to high-altitude interception. It was a machine that commanded respect from every air force in the Pacific, including the United States. The betrayal of the Sukhoi had reached its logical conclusion. The student had not just graduated. He had built a high-tech empire on the foundations the master had sold him. The J-16 stands as a monument to the moment when the copycat label became obsolete, replaced by a reality where the original master was left looking at his own creation and realizing that he was now the one who was falling behind. It was no longer just a jet. It was a declaration that China had arrived at the absolute forefront of the aerial arms race, and they had done so by taking a foreign legend and forging it into a domestic powerhouse. To understand the full weight of the journey that began in a freezing Russian hangar in the early 1991s, one only has to look at the flight line of a modern Chinese airbase today. Row after row of dark gray, low-visibility fighters stand ready, their surfaces smooth and their cockpits glowing with the light of high-definition touchscreens. This is the J-16, a machine that has quietly become the iron backbone of the People's Liberation Army Air Force. It is no longer a guest in the Chinese inventory. It is the master of the house. The story of the Sukhoi in China has reached its final, most ironic chapter. The student who once sat in awe of Soviet genius, struggling to understand the basic metallurgy of a turbine blade, has not only graduated, but has built a digital empire that is now casting a long shadow over its former teacher. The flanker airframe, once a symbol of Russian dominance, has been split into two distinct lineages, and the world is beginning to realize that the Chinese branch of the family tree is the one growing toward the light of the future. The most telling comparison in modern aviation is the head-to-head analysis of China's J-16 and Russia's latest masterpiece, the Su-35. On the surface, the Su-35 is the more heroic aircraft. It is a triumph of raw kinetic power, equipped with thrust vectoring engines that allow it to dance in the sky like an acrobat, performing maneuvers that seem to break the laws of physics. It is the ultimate expression of the Russian philosophy that a pilot's skill and the aircraft's agility can win any dogfight. But the Chinese J-16 represents a different, more modern philosophy, the philosophy of the information age. While the Su-35 is a master of the physical realm, the J-16 is a master of the electromagnetic one. With its superior active electronically scanned array radar, its integrated high-speed data links, and its ability to act as a command hub for swarms of drones, the J-16 is designed to win the war before the dogfight even begins. It is the difference between a master swordsman and a sniper with a thermal scope. One is beautiful to watch, but the other is far more likely to survive the 21st century. The irony of this evolution has now spilled over into the global arms market, creating a reality that would have been unthinkable to the Russian designers of the 1990s. For decades, the flanker was Moscow's most reliable export, a high-end alternative for nations that wanted American-level performance without American political strings. But today, the Kremlin watches with a mixture of frustration and silent respect as China begins to dominate the very markets they once owned. Whether it is through the export of the J-10C or the burgeoning interest in J-16 derivatives, China is offering something Russia currently cannot: a marriage of a rugged, proven airframe with the world's most advanced microelectronics. Nations in the Middle East, Southeast Asia, and Africa are increasingly looking to Beijing, not just for planes, but for the entire digital ecosystem that comes with them: the satellites, the precision-guided missiles, and the artificial intelligence. The student is now competing with the master for the same customers, using a refined version of the master's own blueprints to win the deal. But to view this saga as a simple story of intellectual property theft is to miss the far more profound lesson of the J-11 and J-16. The betrayal of the Sukhoi was not just about stealing a plane, it was about stealing the ability to innovate. When China tore up the contract in the mid-2000s, they weren't just running away with a set of drawings. They were betting that they had learned enough about the process of creation to survive on their own. They spent the next 20 years building a massive industrial infrastructure foundries that can produce single crystal turbine blades, laboratories that can write millions of lines of flight control code, and factories that can mass produce composite materials at a scale the world has never seen. They didn't just copy the flanker, they used it as a bridge to cross the technological chasm. By the time they reached the other side, they had transformed their entire nation into a first-tier aerospace power. This was the price China was willing to pay. They accepted the international condemnation, the fury of Moscow, and the label of copycat, because they understood that in the world of great power competition, there is no such thing as permission. Sovereignty is not something that is granted by a teacher. It is something that is seized through industrial will. The J-16 is the physical manifestation of that seizure. It represents the moment China decided they would never again have to ask a foreign power for the engines to guard their own sky or the software to target their own enemies. They took the Russian Trojan Horse and turned it into a domestic dragon. Today, as we look at the legacy of this 30-year drama, we see a Russia that is increasingly isolated, struggling to maintain its lead in a world defined by chips and code rather than steel and fuel. Meanwhile, China is already moving beyond the J-16, using the lessons learned from the flanker to build fifth-generation stealth fighters like the J-20 and carrier-based jets that will define the next 50 years of Pacific history. The Su-27 was the spark, but the fire is now entirely Chinese. The student has surpassed the master because the student realized that the machine itself was never the goal. The goal was the knowledge of how to build the next one. The betrayal of the Sukhoi was a cold, calculated transaction where a bankrupt superpower sold its past to a rising one, only to find that in the process, it had also sold its future. The J-16 flies today not as a copy, but as a monument to a nation that refused to remain a student, a plane that represents the final, unyielding victory of indigenous innovation over imported dependence. It is the rook on the chessboard that has finally reached the other side, transforming into a queen that now dictates the rules of the game.